we are going to find all real values of x such that f of x equals 0. So what does it mean? Let's look at A. F of x equals 15 minus 3x. When it says find all real values of x, we have to find x, right? That's what it's saying. We have to figure out what x is. So obviously this does not mean let x equal 0, because it's saying we have to find values of x such that f of x equals 0. And we know that f of x is the same thing as y, right? So we're going to uh, set the function to 0. This represents the function. And here, if we look at example A, f of x equals 15 minus 3x, that's our function. Our function is this, 15 minus 3x. So we are setting 15 minus 3x to equal 0. This does not mean set x to equal 0, because obviously if you read the instructions, it's saying that we have to determine what x is. It did not give us what x is. We have to do a little work for that. All right, so if we look at A, right? So if we are to set f of x to equal 0, then we are setting the function in A to equal 0, which is 15 minus 3x equals 0. See that? We are setting the function to equal 0. And then, of course, we solve. We could add 3x, or you could have subtracted 15. But I like adding that 3x here. We have 15 equals 3x, divide by 3. Therefore, x equals 5. So for this first problem, we have found the x. The x equals 5. So for these problems, again, you are not letting x equal 0. We are finding what x equals. So what does it mean really? It means that if we evaluated this function at 5, and we evaluated this function at the number 5, that's the number we found, we get 15 minus 15, which equals 0. That's what we wanted. What x value will result in the function equaling 0? And it is the value of 5. All right, next, let's just go forward here. Just set x squared minus 9 equals 0. Here we have a quadratic. So normally when the degree is higher than 1, more than likely, we usually have to factor or use some other method to solve for x. So this is a difference of squares. So x plus 3 equals 0, or x minus 3 equals 0. So here our solutions are x equals -3 and +3. All right, next we have the function 3x minus 4 over 5. Again, we are going to set that function to 0. This is rational. To get rid of that denominator, let's multiply by 5 on both sides. We get 3x minus 4 equals 0. Add 4, 3x equals 4, divide by 3, x equals 4/3 for that one. Then we have D, f of x equals x cubed minus x. Notice our degree this time is 3. Therefore, more than likely, we're going to have 3 different answers. So we set x cubed, our function, x cubed minus x, to equal 0. Again, we have a polynomial that is of degree that's higher than 1. So we usually use techniques or strategies or methods other than just adding x. We can't do that here. So we are going to factor the GCF out. We have x squared minus 1 equals 0. And notice we have another factorable situation. That's a difference of squares. So make sure you recognize when you see difference of squares. X plus 1 times x minus 1 equals 0. X equals 0, or x plus 1 equals 0, or x minus 1 equals 0. So one solution is 0, another solution is negative 1, and we have positive 1. So there are 3 solutions to this problem. Okay, the next problem says find all real values of x such that f of x equals g of x. So that's a different instruction than find all real values of x such that f of x equals 0. This one, we at the top, we set the function to 0, and for this set of instructions here, we are setting the functions equal each other. So if it says we're still finding x, but it's saying set these two functions equal each other. So guess what? We're just going to replace our function with what our function equals, right? It said that f of x equals x squared. So we're going to replace f of x with x squared equal. And we're going to replace our g of x with x plus 2 and solve this equation. Again, we have a situation where we have a degree 2 higher than 1, so we know that we have to use a different method. If everything is not on one side, here are the steps. We first have to move all terms to one side. So that means we need to subtract x from both sides, as well as subtract 2 from both sides. That way we'll get x squared minus x minus 2, because we want it to be set to 0. All right, so now we have it set to 0. That's where we want to begin. All right, the next step would be to factor. So we need factors of negative 2 that add up to negative 1. Right? So what are the factors of negative 2 that add up to negative 1? So we definitely have x times x will give us that x squared. We know factors of positive 2 is 2 and 1. But we got to figure out what would make it work out so that we end up with a negative x minus 2 right here. So 2 would have to be negative and 1 would have to be positive for that to happen. So the next step, write the next step down. Next step would be to set each factor to 0 and solve. So we have x plus 1 equals 0 or x minus 2 equals 0. So x equals negative 1 and x equals 2. So those are the solutions for A. Find all real values of x such that f of x equals g of x. So you can test it out. If you plug in negative 1, on the left side here, you get negative 1 squared, which is 1, right? And if you plug in negative 1 on the right side here, you'll get 1 on both sides. So it says find all real values x such that your function is going to equal each other. Well, they do. All right. We get positive 1 on both sides of the equation. All right, B. Still using those instructions, find all real values of x such that f of x equals g of x. So we're going to set these functions equal each other. So we're going to set square root of x minus 4 equals 2 minus x. Here we have a radical equation. Radical equation. And if you recall from Math 100, there are certain steps that you have to take in order to solve a radical equation. First step is to isolate the radical. So isolate means we want that square root of x by itself on one side. Therefore, we need to add 4 to both sides. We would get the square root of x equals 6 minus x now. Now we need to get rid of that radical. This is a square root, so we're going to square both sides in this case. Now, if it was a cube root, we would cube both sides. Cube, dot, dot, dot. All right, just in case it was a cube root. Now, we have, let's go ahead and square it here. Square that side and square that side. So what do we get? On the left side, the radical in the squaring or inverses, so we get just what's under the radical, which is x. On the right side, we need to write this out twice. That's how you square a binomial. You write it out twice and you 4. So that's 36 minus 6x minus 6x plus x squared. X equals 36 minus 12x plus x squared. Again, we have a situation where we have something on one side, we got an x squared on the other side. We got to go back to the steps that I wrote down earlier. Beginning here, move all terms to one side. Move all terms to one side. Then factor, then set each factor to 0. All right, so if I move all terms to one side, that means we got to subtract x. That would be 0 on the left side now. That's what we want. Let's put this in descending order, so x squared will come first. What is negative 12x minus 1x? It is negative 13x plus 36. Then we factor. Factors of 36 that add to negative 13 be 9 and 4, and will be negative for both. We'll set each factor to 0 and solve. We get x equals 4 or x equals 9. Now, the last step of solving radical equations is you have to check answers. You have to check each answer. All right, so we would check each answer separately. We would use that original square root of x minus 4 equals 2 minus x. So 4, x equals 4. Does it work? Let's see. Square root of 4 minus 4, does it equal 2 minus 4? Square root of 4 is 2 minus 4 equals 2 minus 4. Looking pretty good here. Negative 2 equals negative 2. So x equals 4 is a solution. But what about 9? So I'm going to erase this. Let's check to see if 9 works. All we want to see is, does the left-hand side equals the right-hand side? So the square root of 9 this time minus 4, does it equal 2 minus 9? Well, the square root of 9 is 3 minus 4. 2, not looking good, not looking good, because 3 minus 4 is negative 1, and 2 minus 9 is negative 7. Negative 1 does not equal negative 7. Therefore, we can rule out 9. X equals 4 is the only solution to this radical equation. All right, let's go over an application problem. A batter hits a baseball at a point 3 feet above ground at a velocity of 100 feet per second and an angle of 45 degrees. The path of the baseball is given by the function f of x equals negative 0.0032 x squared plus x plus 3, where f of x is the height of the baseball. So let's at least write some stuff down. This is the height of the baseball. And x is the horizontal distance. Horizontal distance. Horizontal distance. X represents the horizontal distance. All right. From home plate. From home plate. Will the baseball clear a 10-foot fence? Sounds like a height to me. This really does sound like a height. 10-foot fence located 300 feet from home plate. Sounds like an X to me. It says because if you notice here, X is the horizontal distance from home plate and feet. So that X must be 300 feet. All right. Now, all we have to do is use this function that they gave us, plug in X to see, to get our output. We want to see if our output is, will our baseball, clear a 10-foot fence? So we need to plug in 300. This is our function right here. Let's plug it in. F of negative 0.0032 parenthesis squared. I'm putting parentheses wherever we're going to drop in 300. 300. 300. So that's F of 300 equals, what we need to do here first. We need to do 300 squared first. All right. And then you need to multiply that times that decimal. So pull out your calculator. 300 squared times negative 0.0032. Negative 288 plus 300. And let's go ahead and put 303. Why not, right? 300 plus 3 is 303. We can do that in our heads. Therefore, negative 288 plus 303 is 15. 15 what? Well, our f of x represents our height, and our height is in feet. So it's looking like that ball will go as high as 15 feet. Therefore, it will clear a 10-foot fence if the height of the ball is 15 feet, right? If you have a fence that's 10 foot, then it will clear. So yes, the answer is yes.